So, hi and welcome to another Yule Computer Show stream. Today I have a little bit of a special theme going on. I'm not going to be tinkering with hardware, I'm going to be tinkering with software. And if you watched the previous stream, I realized that I had ordered a couple of STM32 based Bluepill boards to use for my BlueSCSIs that I like to build and put in old computers like that. That Mac SE30 there. Now the eBay seller sold me what they said was C8 T6 variants of the STM32 based product, right? However, what they actually sent me was C6 T6 based boards. So just as a quick check here, this is what I expected to get. The STM32F103C8T6. They are a microcontroller with 62 kilobytes of flash memory. However, what I got was this C6T6, which is the same microcontroller but with 32 kilobytes of flash memory. Now, unfortunately, the BlueSCSI firmware in its current form takes about 47 kilobytes. Let's see what the pre-released version says, or pre-built. Maybe I don't have it here, but we can check in a little moment. So needless to say, we realized pretty quickly that the software wouldn't fit on the microcontroller's internal flash memory. So and unfortunately, also the eBay seller is ghosting me. I unfortunately discovered this too late, and I'm well beyond the official return window, so I'm kind of out of options since the seller isn't being responsive. So why not make the best out of what I have on hand and try to shrink the BlueSCSI firmware down to 32 kilobytes. So I had a chat with the good folks over at the Tinker Different Discord, including the folks who created this device and software, and they advised that there is a good chunk of functionality that we can cut, and it's still being a very functional device. By the way, I did go back and I looked at all the historical releases of the software, and the compiled binary were always hovering around 40 kilobytes, just above. So none of the historical versions will fit onto 32 kilobytes as is either. So yeah, if this works out, I'll share my branch so others can, if they get defrauded by Bluepill sellers, you can potentially use it. So yeah, the leads that I got from the good folks, the creators of this software, and others who contributed is the cd-rom support, right, the optical device support. Very firmly optional, especially if you use it with an older device. So that's one thing. Another thing is the exFAT file system support. FAT32 is a bit slower than exFAT, but if you use it on an older Mac, perhaps the SE30 is borderline, but 68K based Macs, etc., you don't necessarily need a faster file system. And if we want to go even more hardcore, we can potentially remove a couple of the implemented SCSI commands that aren't used by, let's say, an old Mac. That, of course, to do that right, it's good to have understanding of the SCSI spec, which I honestly don't really have. I have surface level understanding of this stuff. So consider this a hack maybe you can call it a hackathon, although it's just me. So yeah, let's jump straight into this. I'm gonna, let's see here. So this is the computer screen. Let me put myself, just a moment. I think I'm gonna add myself here. Perhaps, yeah, perhaps in the corner there. And then jump over to Visual Studio Code here. So yeah, this is, I'm running Windows 10. I have Visual Studio Code with the Platform IO plugin. I have a C compiler all set up. And yeah, I also, of course, have a Bluepill here with the ST-Link v2 programmer. So first things first, let's connect this. So now the Bluepill is connected. Actually, let's see if I can. I want to be able to see what's going on in the chat, for instance. Hi, Eric. Thanks for joining. Yeah. So, guess friend of the channel, Eric Helgeson, the creator of BlueSCSI. He's probably the best person to tell us all what's going on here. So yeah, let's first of all let's observe what happens, right, when we try to program this 32 kilobyte flash memory with the existing version of this code. Let's head over to the Platform IO tab there. We pick our main build task. So once we hit upload here, it's gonna build the code and try and upload it. It just takes a moment. So oh, your video is a bit over the code. Okay. So I guess this is the problem with. Maybe I should try and connect another screen. But anyways, just to see what's going on. So it starts the verification and then it fails, right? Obviously, because it cannot write all the code to the storage. And what we get the concrete error is no flashback found for address, and then the address, right? So basically can't find flash storage to write to. And then it errors out there. And another thing we can get here, I think, I guess up here. So you see here flash, it says 48,900 bytes, right? So that's what, about 47K, I'd say. So it thinks it has 65,536 bytes, because I think that's what the profile for this code says, but yeah, it obviously doesn't. So yeah, our task should be to get rid of code that we don't need, and then we'll see. You know, we'll run the upload task. Right? Let's. What happens if we just build? Do we get the same then? Can we see how big it is? There. Okay. So the build task can tell us how large of a binary we're getting. Exactly. So how much is 32 kilobytes? 2 times 4, so 32,768 bytes. Sounds about right. So that's what we need to get to, I think. Anyways, so the BlueSCSI code base is not very large. We have one C++ file, so this is sort of the main code, and then we have 6 headers. No, sorry, 5 headers. So I think it's not a bad idea to start out to look at the headers to see what kind of constants are being defined, if there are macros, stuff that we can immediately say, hey, we don't need this. And I think if we start out by commenting them out, the code will very quickly tell us what other parts of the code base relies on that. So yeah. So I have to kind of switch back to this view in order to see if there's anything going on in chat. I'm not sure if there's a better way to do that. Can I get like let's see here. Maybe not. Can I set up my phone to see live chat? I'm just gonna quickly head into the YouTube app and see if there's any functionality I get here. Let's see here. Can I see myself live? My channel. Live. Yeah, I can watch myself live. Okay, so I'm gonna be using my my phone to see if there's any chat that comes through. And I'll go back to the full screen computer window. All right, so let's just start to go through this. First, I'll just glance over the whole thing to make sure I understand what's going on here. And then I'll probably take some notes along the way to see if I think of if there are other things that can be cut. Excuse me. So we start out by defining a couple of base settings, number of SCSI IDs, number of LUNs. By the way, that could be another thing. Perhaps we don't need. If we need LUN, we should at least always hard code to 0 LUNs, or to just 1 LUN rather. LUN 0. Yeah, it's there. Default SCSI LUN. So yeah, LUN is logical unit number, which means you can have 32 logical units per SCSI ID, which is not really necessary for a consumer computer. We don't really need more than 7 devices ever. So yeah, we already enabled just the 1 LUN, default SCSI ID, default SCSI LUN, buff size, HDD block size. I don't think we need optical block size. We're gonna get rid of optical support, so we can just start by commenting that out. Max plus block size for HDD, SD1 config. Oh yeah, that's right, Brandon. Welcome to the stream. Yes, I'm gonna try and shrink the code down to 32K, or the compiled binary down to 32K, to see if we can fit it into the crappy version of the STM32. Enum SCSI device. So we don't need the optical SCSI device type. I don't know if we can convert that to us. We don't need the enumeration for that, but for starters, let's see what happens if we just comment that one out. We don't need cd-rom dual sector size. We don't need common sector size. SCSI command handler, if debug. So I think that as long as the debug symbols aren't activated, they will not be compiled into the binary. So I don't think we need to care about getting rid of debug. That should just be deactivated by itself. Although every other logging, I'm pretty sure, yeah, all of the other logging strings and stuff like that, and logging libraries, whatever. Is there like a library? No, just Arduino H is DFAT. So no logging library imported here. So I'll just make a note of that. Perhaps we can discuss shrinking ideas. So all of the info logging. Well, thanks, Brandon. Yeah, let's see how far we get. Activate high-low GPIO stuff. We need that. Read and write. So here are SCSI. What is this? Attention busy. Acknowledgement, reset, message, select, CD, rec IO. So these are SCSI commands? I don't know. STCS, LED, LED2. Oh yeah, that's the LED code. I guess, do you want to get rid of the LED code? Probably not. That should probably be very little code. But I'll put it on there, just LED. Image set select. I'm not sure what XCVR is. Pin definitions. Okay, got it. So these are the pin definitions. Thanks, Eric. Reset port, LED control. So yeah. Hi Xenocide. Virtual pin, Arduino compatibility slow, so make it MCU dependent. Virtual pin decoding. SCSI output pin control. SCSI out. SCSI input pin check. I think we need that. XCVR is for transceiver boards, but off by default. Okay, cool. So that won't be compiled in either, obviously. The ID tells me that it's gonna be, it's kind of faded out there, the text is high. Yeah, we don't need to worry about that, I think. SCSI timing delays. I think we need that. SCSI phases, so here's the diagram. Direction transfer. Yep. SCSI phase change, phase mask, phase XCVR. We don't have to worry about that. It's all disabled. It's more core SCSI stuff. I think we need that. Pair to bit generation. BSRR. So yeah, I don't claim to understand what's going on here. I won't be touching this unless Eric tells me otherwise. Parity. Reading the data bus. Okay, here we go. So inquiry data for SCSI. Bit fields are in reverse order for ARM. So inquiry is, so I understand it, is the SCSI command where the host asks the SCSI device what it is, and then it will respond. So the obvious user-facing responses that I'm familiar with are the vendor product revision. So some of this will be exposed if you use like a SCSI tool, like SCSI director or something. It will tell you some information about the device. We probably need that. Hard drive disk image, SCSI device. Optical raw sector size. Again, optical. But okay, why is it part of? Okay, I guess this comment is not entirely accurate then. Let's comment that out for now. See what happens. Device type, block count, raw disk. SCSI information. Mode 2 cd-rom. For now, let's just comment out something that seems optical related. CDV lane lookup. I'm not sure what that is. All right, that's the main header. It's not too complicated. Let's just keep looking at all of the headers, see what we find. These are the SCSI commands. These are very important. So this is where, yeah, I think Eric, you suggested that some of these may not be absolutely necessary for, let's say, an old 68K Mac. But for now, let's at least remove what's obviously optical related. Table of contents for cd-rom. We don't need that probably. Oh, here's a lot of cd-rom. Can we do multi-line? Anything SCSI 2 won't be used. It's interesting, yeah. It seems so counterproductive. Is SCSI 2 such a new standard that 68K Macs were basically the SCSI interfaces were created before the SCSI 2 standard? Is that correct? So I'll take that as a potential next step if we don't get it small enough to mess with that, because I have to read up on the SCSI 2 spec to understand what is new in SCSI 2. Anyway, SCSI mode. I think we need, seems like we need that. SCSI sense. Yeah, so these are some statuses for the SCSI device. Non format. Not ready. Mode page. Some obvious cd-rom related. The cd-rom and CD audio control. Vendor Apple, isn't that Apple's cd-rom hack stuff? Eric says we ID as a SCSI 1 device, so nothing will send a SCSI 2 command to it. Okay, that makes sense. All right, moving on. SCSI status. Good, check condition, condition met, busy intermediate condition met, conflict, command terminated, queue full. All right, string for CDs, right? Yeah, that's what I recalled. So we don't need vendor Apple. All right, so we got to start there with the header. Let's have a quick look at the actual program. So yeah, we have the version string. So logging again, that's the next step. If we can't compress it enough, we can probably remove the logging stuff. We pull in all the headers. There's nothing else. We don't use STM32DMA, it seems. That was that direct memory access. STFAT. So that's the library as well, the STFAT library here. Oh, we have the setGMP as well. Oh, remove any strings, we'll save a lot. Okay, cool. Yeah, that could be the easy first step. Even if we don't remove the logging, we can just log nothing, right? That's the easy way to do it. Let's make a note of xfat, so don't forget. Pass reset jump, SCSI ID mask. So put a bunch of variables that we will use. SCSI buff size, storage bytes. Enable SCSI IDs to be representing as LUNs on SCSI ID 0. This supports a specific case for the Atari Mega STE internal SCSI adapter. I don't think we need that. I don't know. Let's see what happens if we comment that out. Function table, command handlers. So yeah, we don't need to read TOC. That's a cd-rom thing. DVD structure, we don't need that for short disk information. Probably optical related. MSF to LBA, LBA to MSF. Thanks, BlueSCSI. Nowadays called PiSCSI. Yeah, maybe Eric can explain what that is as well. I'm not sure. Static void flash, or this is, I suppose, the method that flashes the LED upon error. So potentially, we can potentially remove that. We don't really need that error reporting, potentially. Bus reset, init file logs, yeah, so we can potentially remove that. File log, find drive images, we want that probably. Read IO, GPIO, parity check. Oh, that's disabled. Config file. Oh, actually, that could be a thing as well. Which one was for CDs? Oh, MSF to LBA and LBA to MSF. Okay, so the flash code supposedly would only save us a couple of bytes. So yeah, we could potentially remove the config file support. Config file. Because that's a bunch of stuff going on here. We need to open a text file for reading, and then we need to parse it and log a bunch of stuff. So that could save us a good chunk of space. Read SD information, print a log file, read SD card. Yeah, so a bunch of logging here. So my idea is the first pass should be removing the optical device code, and then we build it, see how large it becomes, how small it becomes, and then we'll tackle the next lead. Verify ISO PVD. So this ISO suggests that this is cd-rom. There are lots of cd-rom going on here. Yeah, so I suppose we can get rid of that. Get rid of SD card info and config file parsing. Yep, will do. Open HDD image file. Okay, HDD image open. We probably need that, although maybe there's something inline. Yeah, so logging we can remove. A bunch of logging here. And if device is SCSI device optical. All right, that can go. How far does that go? Else log file print HDD. Can the ID tell me? It's down to the else, okay. We don't need the else, I think, because that's just log. Block size dummy file, bunch of logging. If device M type is SCSI device optical, so logging can definitely remove that. We will probably want the error handling. I'm gonna close out the file and stuff. And now, okay, here is the initialization. Cool. Enable debug ports. We don't need the JTAG. Let's just get rid of that. BSRR table, I'm not sure what that is. Default all SCSI command handlers to unimplemented. I don't know if that's important. 0 all SCSI device structs, probably important. And SCSI commands that just need to return OK. So I suppose if we know which ones of these are not important, we can probably remove that handling as well. But maybe this is a very small saving. We should get rid of. Okay, so the ID very helpfully tells me that these are undefined. These, excuse me, constants are undefined. So yeah, we can just get rid of those. Clear and initialize default inquiry blocks. Default vendors. By default, we identify as Quantum BlueSCSI F1 version 1.0 device. We don't need the cd-rom stuff. Debug should already go. They are not all important, but no op does nothing and only bits. Okay, so it's not too much saving to mess with these no ops. Pin initialization, image set select unit, LED off. SCSI DB input, XCR input port. So a bunch of GPIO initialization. Occurs when the reset pin state changes from high to low, attach interrupt, reset and bus reset folding. It's already commented out. Try different clock speeds till we find one that's stable. I suppose this code is particularly useful for the variants of this microcontroller. If we know exactly what our microcontroller is running at, I suppose we could hardcode this, maybe. Oh, here's that's pretty cool. Yeah, you can see this is the flash error method, and this is the famous 5 flashes, right? Because error no SD card is defined as integer 5. So yeah, flashes 5 times when there's no SD card. Read discarding init file log. So there's more logging. SCSI ID mask. Look for this file to enable MST mode. What is this? STX is MSTE mode. I'm not sure what that is. Constr MST mode. Omega STE. Okay, of course. It's an Atari thing. We don't need that. Any chance you can move your camera to the lower right? It's blocking the area you're working on at the top left. Ah, I see. I see. I can make myself smaller as well. Lower right. Yeah, it's a good point. I'm often messing around up here. Make myself even smaller. There. image set X. Oops. Yeah. Iterate over the root path in the SD card looking for candidate image files. Probably want that. We don't need the logging probably. Images all there. Error with 0 image files. LED off. Find drive images. And oh, here's a loop. Directories cannot be opened read-write, so it will fail, but fails the same way with no file there. So we need to peek first. Okay. Skip directories, already open files, edit file, switch to lower. Yeah, we don't need this case. Defaults for hard disk, ID equals 1, LUN equals 0, block size equals 512K. Remove images set support. Which one was that? I really dislike how YouTube gives you comments like 15 seconds late. Image set, oh, here, okay. Chart image set their name. Oh, I see. Set their name. Image file sets. Oh, it's all of that. Root is directory. So it's all this. Positionally read in and co-erase the charts to integers. We only require a minimum and read in the next if provided. File name length is greater than 2. Temp ID name, HT image ID position. Right, so it's looking for the ID position. If it's valid ID, yada yada. And then it looks for LUN. So that could be a thing. We could remove the LUN support and always default to 0. Let's put that on. LUN support. Oh, there's more image set. I'll do another pass, see if I can find more image sets once I get to the bottom here. Okay, block size. This could also, we could also hard code this to 512K. We could remove that feature. Block size support. Right, so this is where it's kind of trying to parse and understand what we're telling it to use. Oh yeah, we can hard code. That's right. Oh, yeah, thanks, Brandon. That's a good tip. Control / to comment an entire block of code. Hard code needs to be read. is HDD. Yeah, what's going on here? If ID is lesser than number of SCSI IDs and LUN is lesser than number of SCSI LUNs. I guess that's a check, so if you're using more than that, you get an error. Or it bails out. This works. Yeah, look at that. That's convenient. All right, set up initialization log file. Oh, here's my logging. So this could save us a lot, potentially. More logging. Here's the flash error. Yeah, it's very small. Return for it from exception and call long jump. Probably important. So this is something to do with jumping from one address to another. I'm not sure. Bus reset interrupt. Probably important. Enable reset long jump. Read by handshake. Write with a handshake. Optimization. Okay, so here's a write data loop. It says this loop is tuned to repeat the following pattern: set rec, 5 cycles work delay, wait for ACK. Cycle time tunings are for 72 megahertz, STM32F103. Alignment matters. Yada yada. Yeah, so this seems to be a pretty core part of the the operation of this device. I'm not gonna be messing with this, I think. So here are the different SCSI phases. I've seen this when I've poked around in PiSCSI code as well. These write data phase, read data, read data, SD. Data out phase, compare to SD card. Yeah, I'm not going to touch this. Message in. Handshake. Oh, main loop. All right. So we're at the meat of the program now, the core. Here's the loop. A message, mlun, SCSI device, do while. Target active, busy active. Reset, going to bus free. If is high, GPIO read ATM. In SCSI 2 this is mandatory, but in SCSI 1 it's optional. That could be a thing then. Is this something that can be removed? SCSI 2 stuff. We log the command phase change. Log hex, command length calculation, LUN confirmation. So logging, HDD image selection. request sense. Okay, so if the device is not a known SCSI device, then there's some error handling. So here's some code for status and bus free commands. Are they commands? I don't know. SCSI target inactive. And if. Alright, that's the end of the main loop. Static byte on unimplemented SCSI device does nothing. Unimplemented SCSI command. So some error handling. Eric suggests focus on the meat, which is the extra file objects, logs, file parsing. Okay, so the SCSI commands are only a few bytes too. They shift around some data, respond, reuse buffers, and things, so almost no savings. Okay, yeah, seems like ROI for messing with that should be fairly low then. Query command parsing, request sense. Read capacity, probably want that. Check block command, block range, probably want that. Well, so these are, okay. On read 6, so these are some of the device or the SCSI commands going on here. Right, so I suppose this is where we're implementing these ones, right? Read 6, write 6, 6, 6. Write 6, write 10. Oh, there's some optical going on. Oh, actually, was that the first one? Yeah, we don't need this branch for optical stuff. Unverify, mode sense 6, mode sense 10. Hard drive disk support page codes 1, 2, 3, and 4. cd-rom supports page codes 1, 2, D, E, and 30. So we definitely want the if SCSI device HDD branch here, but I expect there to be a, oh, here we go. There's the vendor Apple. We don't need that because that's cd-rom specific. This stuff. And here's the else branch for optical, which we don't need. And this one too, I guess. No, we need the last bracket. This one we need, right? Because that goes with... No, I'm not sure. This one goes with this, and that one goes with that. What does this one go with? Oh, up here, okay, on mode sense. We need that. But now we're getting expected declaration. So we messed something up. Oh, is it this? Oh, there we go. Okay, we didn't need that. Set block length on node select. Here's a branch for optical. Debug. 0 unit, write buffer. Read buffer. Some diagnostic. Read defect data. Oh, TOC we now get rid of. Read disk information, we can get rid of. DVD structure, don't think we need. And LBA to MSF, that was cd-rom related. And all right, that's the end of the code. That's pretty manageable. So let's see, it's gonna be interesting to see if this code still builds and how how large the binary is gonna be. So let's do that right now. Let's build this code, see what happens. Very sad. So yep, we need to do some cleanup. SCSI device has no member sector offset. Yeah, we removed that. We removed the block size. Maybe just to make it easy for us this time around, I'm gonna restore those. See, where was that? It was part of some struct, right? Sorry, I got lost. Yeah, it's definitely in this somewhere. Oh, there they are, okay. Yeah, so let's just put these members back. Okay, let's see what it complains about now. Deleting, oh, so this is just a warning. Don't think we need to worry about that. These are warnings. Okay, so mega STE mode, we can remove that. How do we jump to that? I'm gonna paste two lines now. Open file in editor. There you go. We can remove that branch. Let's build again. All right. Success. But did we save anything there? I should have taken note. There it is. So 48. Let's see, I'm gonna take note. This is the original. Can we copy this? Original size 48,900 bytes, and then after first pass, it's mainly cd-rom related, we achieved a whopping 2K. $46,928. So we have quite a long way to go. So shall we try logging for starters? That seemed like a low-hanging fruit. Doesn't really make anything worse. I guess at this point, so let me I'm gonna save a snapshot here. Yeah, 2K is something in the world of a microcontroller, embedded devices and microcontrollers. Yeah, 2K makes a difference. So let me see here. I'm gonna go. I think I have. No, that's not it. So I think we have BlueSCSI here. So I'm gonna just create a branch for me. It's always good to take a snapshot of where you had working code halfway through, so you can easily go back to that. Remove cd-rom. Oh, yeah. So by the way, I'm on a quote-unquote new computer. I got my gaming PC out of the living room. I beat Elden Ring a little while ago, and I no longer really felt the need to have a gaming PC in my living room. So I'm using this for this purpose instead. There we go. We have a commit. All right. So let's get rid of logging. Remove log file. Log file. Aha. That's the file object, huh? So yeah, let's get rid of log file. Will it? What happens now? Will this still build? I bet it will error out. Yeah. Unused variable. Apple Magic. Oh yeah, can probably remove that, right? Never mind. Is there some log stuff defined here? I think so. Let's just search for log. Define log xx. Yeah, that might be. Let's see what happens if we just comment out all of this. That's it. Yeah, debug is off. Oh, we can't see your console window. Do you have a console window? I don't think I had a console window up. Oh, is it the terminal down here? Is this stuff down here? leave the bottom half. It's literally turning any log function to nothing. The bottom half as in all of these four. So I guess it doesn't matter. Problems output debug terminal. If it's open, it will show all the uses of log file. Ah. Go to references, peek, find all references. Yep, it's a good chunk. Config file read bytes. It's just a bunch of, oops. Read SD card info. Do we need that? Find log file, replace with comment log file. Yeah, it's good. Yeah, I guess that's easy. Replace in files. Search. Log file. Place. Log file. Oops. Underscore. Did you do that? Replace all. Yes. Okay. Will this still build? Let's see. Does not build. Okay, sure, we can, I guess we can remove that. Oh, what's this? Oh no. 2 or more data types in declaration. That's just a warning, right? Okay, we can remove the whole SD card info. Is this called from somewhere? Down here. Can we remove the init file log? Command line 62. Ah, of course, yeah. Of course. Yeah, I'm getting a little bit tired, losing focus here. Need to stay on top. The errors are expected primary expression before bracket token. So that seems like some very basic syntax error. Look at the chat. Oh. Depending on how hacky you want to be, just to define log file .print xx. So that is, you said there's overwrites the logging with nothing. Yeah, so we don't need this at all, I think. It's just some logging init file log. Guess we can just remove that as well. And can we see if this is used anywhere? We don't need to declare it. Finalize file log. We can probably don't need that either, I think. We don't need this either. All right. It builds again. That's nice. 44,240 bytes. So that's another 2K after a second pass. Logging. 44240 bytes. After this, change find drive images to hard code to one file, then I think you'll be close. Ah, okay, the other file handling, huh? We don't want to mess with files. New database. If I can find that stuff again. Oh, find drive images, I guess. Okay, so fs file pointer to file equals null. So this is where we just don't do this. Yeah, that's right, Tony. It's a variant of yeah, like Eric says, it's the C6T6. I had them up here on the data sheets here, just at the beginning of the stream. So this is what you should be getting when you want to build a BlueSCSI, and this is what I ordered on eBay, but the eBay seller sent me this, the C6T6, and I didn't notice until the return window had closed. And well, I was thinking that perhaps others are getting defrauded as well and have a bunch of 32K, it says right here, it's 32K flash memory, Bluepills sitting around. So rather than throwing them in the trash, you could always potentially use them. You need to set up a SCSI device, open one file. Yeah, darn eBay. and shame on me for not actually building the BlueSCSIs until a couple of months later. I should obviously have built all of the BlueSCSIs instead of putting the parts in the drawer and not building the BlueSCSIs. Yeah, so this is the part where probably a little bit more brain power will be needed. Yeah, we should get rid of the file handling. All this opening up the SCSI device dev equals. So we want to potentially just assign this something, you're saying, instead of messing around with file system stuff. All of this, huh? Look at the end where we create. Discuss device lists ID LUN. Oops. We can just hardcode that, maybe. Type is device type equals SCSI device HTD. Image ready equals HT image open dev file ID LUN block. So dev is this, file is, so this is, we can just hard code this to HD1. And HTD image open. Image ready ID mask. So what we do 10512. Where's HTD open? Ah, HTD image open. Oh, that one, right. Something like that. Do we need the image? I guess we need image ready. We don't need path name. Get name is good. Change dir now. Discuss device. We don't need this check, I'm pretty sure. You don't need to cd. Do we need this stuff? The image ready stuff? Argument type const char is compatible with parameter of type fs file pointer. Identifier dev is undefined. So we got rid of too much, right? Just gonna have a quick look. Oh, that's where we defined SCSI device. Still need that. So HD image open expects to have an fs file. Argument. So should we hack HD open? Or do we still need that? I guess we need that. It's a base file with Arduino stream. So how do we how does file get, what kind of data type do you need to pass it? File equals new SF file st open. Oh. Oh, read the chat. Don't need to allocate the fs. Oh, really? So should we hack a HD image open? Oh, sorry. HD image open takes a fs file, not a char. So it takes an fs file type argument, but you're saying we don't need to allocate the fs file. Oh. Huh. Oh yeah, it's at the top messages. Chat filter all messages. Yes, that's fine. Yeah, I get all messages now. I just didn't notice the earlier. Yeah, sorry, brain freeze. So how do we get the of course. And file is file. Then it opens it. Yeah, it's file. Fine. So I just don't quite understand the FS file data type. Well, FS file, that's the Arduino file data type. It's ready. Open for reading and writing. So this is what we need to do, right? We just need to we need to open the file name. Okay. Let's try to build that, see what it says. Okay, so it built it, but did that make a difference? Yeah, a little bit. So another 2K, huh? After third pass. So that's the image file. Four 2 3 0 0. Okay, so we're still about 4K away. So, what other leads did we have? Logging. Yeah, the SD fat. No, we haven't touched the fat stuff. Config file loading is the other thing. The read discuss device config. Use long file names equals 0. Oh, okay, that's a flag. Use fat file type equals 1. Check flash program 0. Where do you actually, it reminds me we should where do you pass project code? Here are the build flags. Here are the other options for different targets. Right, yeah, the config file is another file object. Okay, let's. I'm gonna copy paste those 3 from the chat here just to make it easy for myself. So let's add those to the build flags. Debug none. Okay. Let's see if we can still build this. No, it's reloading the target. Come on. There we go. Let's build. Failed. So ds fat file type equals 1, not found, needed by target. Oh. I should clean. It looked like it, yeah. It looked like it was clean, but let's see if that makes a difference. Oh, what? Oh, it's done cleaning. Okay, yeah, of course. Updating metadata. So it's configuring the project. It's fine. Still can't find that flag. DS defat? Is there a typo in that? Stupid Bing. Can you move your window up? Which window? Oh, we can't see the bottom of the terminal. Huh. I just have where. Oh, maybe. Do I have to? Oh yeah, you're right. Oh, that's so dumb. Sorry about that. I didn't realize that. Oh, there we go. I think that should take care of it. Oops. Now you can hopefully see. Oh, yeah, you can hopefully see the whole thing. The docs are not online. I have to download the zip for the repo. Well, let's try without that flag. Oh, is it just that? Just a typo? Oh, I should clean first. Hey, sorry. Stop. Kill. Kill. Now your face is covering it. Move yourself to the upper right. Ah. Oops. Yeah, let's move this useless face out of the way. It's clean. Build. Yeah, thanks for the feedback. Still can't find dsdfat file type equals 1. dsdfat file type equals 1. Let's try without that for a moment, see if that makes it better. It thinks it's a dependency. Huh. Yeah, that's not right. So, yeah, 4,964 bytes. That is another 2K. See if there are any special characters or something. Sure. Is it this? No. Is it the line ending? Equals 1? There's a red thing. Yeah, it's gone now. Yes, maybe that was some funky line ending. Oh yeah. Chat is far behind. Yeah, you all are living in the past. I'm living in the future. That didn't make a huge difference. What was it? No, I forgot to write that down, but it was 40,964 bytes. 40,000. Oh, didn't make any difference? Huh. Red thing is gone. Yeah, that's what. Yay for IDs. There we go. We have this is a linear curve. We're still pretty far away from 32K though. Pretty far away from 32K. Another 2K, but then we'll be hard up for space. Right, so it's the config file stuff. That's the only low-hanging fruit, right? Where's it called? It's called right here. So I guess it should be as simple as just not calling it and then removing the logic. Oh, hi 1-bit fever dreams. Thanks for joining. We are at the tail end of the a somewhat futile effort to try and get BlueSCSI down to 32 kilobytes. That saved us, what, 300 bytes or so? Just under. $46.92. So this was compiler flags for FAT. This was the config file. So yeah, that's, whatever leads we have left. So we did talk about removing exFAT support altogether. I think the LUN stuff is not, it's already hard-coded to LUN 0, so I don't think that matters. Block size, we don't read it, we just hard-code it, so we hard-code the image to be read, yes. SCSI 2 commands, which supposedly won't save us much. So yeah, I think we're at block count files as block size. Yeah, Brendan, I know that exFAT is more performant than FAT32, but exFAT support is probably heavier, or maybe it's something that's built on top of FAT32. Anyway, I'm just guessing at this point. Image files, oh, unused variable. So I guess, yeah, we don't need the file set, right? That was, we talked about that earlier. GPL stuff, LED, megahertz. Here an SD card. We don't need this now. I think FS file root. Find drive images, we can remove that. FS file image is older. I don't think we need this, right? Here, if there are 0 image files. Find drive images. This is where we hard-coded the one file. Flash error is there. The long jump, and then all the commands. Define SDFAT type 3. Is that something for the header? sdfact define sd1 config. You want to put it here? Oops. Like so. Oh, look at that. 32,064 bytes. Stuff. 32064. That should do it, probably, right? That's what do you say? 32,768. That's 32K. Let's upload. Let's see if this BlueSCSI accepts it. Bam. Whoa! Woohoo! Look at that! Software on the the darn thing. 32 kilobyte crippled STM32. Well, that's that was a surprising sprint to the finish right there. I guess the next next challenge is to make sure that this software still runs, right? Now, I don't have a assembled BlueSCSI, so I probably I'll stream again tomorrow, actually assembling this BlueSCSI. I have all the parts sitting. Yeah, here's my. Let's see here. This is my BlueSCSI parts container. So I'll assemble the BlueSCSI. I don't have one handy with a what's it called, a socket. So yeah, I'll assemble one of these tomorrow, and we'll run this thing and see if it works. So yeah, thanks to all. Thanks Eric, in particular, for all the guidance and basically solving the problem for me. And thanks Tony for the I think the breakthrough was the compiler flags there, so that was super helpful. So yeah, let's follow up on this tomorrow. Thanks you all for calling in and for helping out. See you all later.